Perfect. So, hi everyone, and welcome to Alfa Laval's workshop. Since this is a workshop, I would like to invite you to be as interactive as possible today. So I would like to start by asking you to take up your phone and scan the QR code that you can see on the screen in order to help me to answer a question I have for you. So if you can scan the QR code, then the QR code is still here as well. You can start thinking about which engineering area is most crucial to achieve safe and reliable operation, robust thermal management, and performance maximization. It's civil work, heat transfer technology, or IT. I can see that Betty are answering heat transfer technologies, so I assume that you got the right point of this workshop. We will be talking today about heat transfer technology. And specifically, we will be talking about how Alfa Laval is driving innovation in heat transfer technology for nuclear energy, both in current installations and for the new builds of tomorrow. The agenda of today will start with some welcome and introduction. We'll continue with how we have been innovating the heat transfer technology for the nuclear power since 1964. And we will continue in presenting what are the innovations that we are presenting in order to keep innovating the heat transfer for the new build and the SMR market, and in which my colleague Ron will help me out in presenting the full portfolio that Alfa Laval has currently. And then Ron will close up with some call to actions and closing. And then we will ask again your participation, and we will ask you to choose what you would like to talk about with us. So you're going to, again, need to take your phones up and decide what you want to talk about with us. But this is the end of the presentation. So to start with, the main goal of this workshop is really to talk about how our heat transfer technology can help you enhance the thermal efficiency of your systems and your processes, both in current installations and in the new build. You might already know Alfa Laval, but I chose today some numbers to present our company. Alfa Laval was founded in 1883 in Sweden by Gustav de Laval and has, as of today, 140 years of experience in engineering and innovation. We are a global leading provider of first-class products in three main areas that are heat transfer technology, separation, and fluid handling. And with these key technologies, we are really trying to make a difference in supporting the responsible use of natural resources, minimization of the environmental impact, and enhancing the energy efficiency of your systems. We are a global presence. Our offices can be found in more than 100 countries across the world, and we have more than 22,000 employees. As a testament to our continuous commitment to development, we are reinvesting more than 3% of our net sales into continuous development in R&D, and this can be reflected on the 4,200 patents that we hold as of today. But what do we do in nuclear? We support all types of nuclear applications, from power to non-power applications. We have always sustainability in our mind, and we see ourselves and our technology as future ready. So we really see a lot of synergies between our strength and the requirements of the new nuclear and the SMR market. Standardization, modularization, small footprint, and high energy efficiency are key characteristics of our products. And they really match well with the new requirements of the new nuclear. We also want to stress that we value a lot our customers, and we want to have a customer-centric approach. We want to be there for you from the beginning along all the journey to develop together solutions that are tailored to improve efficiency and boost the performance of your systems. Quality and reliability are also key characteristics of our product, and our products can be designed and manufactured according to many standards requirements of many different countries in the world, up to safety class 2. And we do hold an ASME 3 and stamp license for one of our manufacturing sites. When did everything started? In 1964, we were awarded the large contract to supply the main heat exchangers for the central cooling of a nuclear power plant in the UK, the Wilfa nuclear power plant. Then in the 70s, we expanded our offering into many more positions to cool down water-cooled reactors across Europe, North America, and India. In the 90s, we entered the Chinese market in the nuclear market and the non-power applications. And then in the 2000s, we consolidated the technology conversion, and we have been awarded large contracts for the new builds in China, Russia, and India. Then finally, the 2020 has started, and we saw the start of the nuclear renaissance, in which we really see a push for standardization, modularization, small footprint, and high thermal efficiency that really fit well with our strengths. And what do we see for the future? So our vision is to pioneer positive impact, and we are committed to be climate neutral by 2050. And we really see ourselves as able to support the new nuclear in becoming more competitive in producing low-carbon electricity. So why do we believe that we can make a difference in the new nuclear and SMR market? We are a leading provider of heat transfer solutions, and we do think that we have solutions to solve one of the biggest challenges that is common to every type of nuclear reactor, that is how to transfer heat efficiently. So you can have a reactor that is cooled by molten salt or liquid metal or hot helium or normal, the demineralized water. And all these media will definitely safely and reliably collect heat produced by the nuclear reaction and take it away from the core. But how can you maximize the output performance of your systems? It is really up to the performance of your heat exchangers to prove that you can improve and maximize the cycle efficiency. So our product can ensure robust thermal management that prioritizes system integrity, uptime, and operational safety, but also can reduce the energy losses and can maximize energy efficiency. Our complete offering is not just about product and equipment, but we also focus a lot on services, advices, and training. About the equipment, the key characteristics of our product is about modularity, flexibility, small footprint, and high energy efficiency. And our solutions can be tailored to comply with requirements of all areas of nuclear power plant up to safety class 2, from the turbine island, or from the nuclear island to turbine island, the balance of plant and auxiliary systems, regardless of the type of reactor and the country of installations. Alfa Laval can really cover the heat exchange, filtration, and separation duties across the plant. But also we have a lot of services that we can offer to the nuclear industry, and we provide support, maintenance, spare parts, training, and consultancy to maximize the uptime of the equipment. We have 6 sites that are able to design and manufacture heat exchangers complying with the nuclear requirements, code, and standards of most countries of the world. Our main hub is in Sweden, in Lund, where we can produce gasketed plate heat exchangers. This site is it holds a license for ASME 3 and stamp, and a bunch of other certification like the ISO 19443 and many others. But we also have 2 more sites that can produce gasketed plate heat exchangers, one in China and one in India for the local markets. And then we have 3 sites that can produce fully welded heat exchangers. One is here in France, in Fontanil, one is in Italy, and one is in South Korea. What is our experience with nuclear? We have more than 5,000 units installed in many different nuclear sites across the world. Our strongest installed base is in France, in China, in India, and in Russia. But as you can see, we have experience with many different countries. And how do we take care of our installed base? We describe our offering as a circular path. We start by exploring all possibilities and trying to really define together with the customer the optimal operational and maintenance strategy to ensure long-term reliability and high performance of the equipment. At the start, during installation, we really try to help you to get ready and running and making sure that the equipment is meeting the promised performance and aligns with your production goals. During operation, our services really make sure that you can maintain the peak performance with seamless operation, and we try to offer training and proactive maintenance in order to maximize the uptime of our units. And then during the lifetime of the unit, we also make sure that you can keep to work at peak performance by making sure that you can adapt the unit to changing conditions due to external factors like climate change or system adaptations. And if and when the unit needs replacement, we will help you navigate the change with ease, making as trouble-less as possible the change, avoiding any changes to the surrounding systems. So I promised that I would talk about what we're planning for innovation in the heat transfer technology for the future of the nuclear industry. And of course, our main product has always been, since the 60s, the gasketed plate heat exchangers, that we're still keeping innovating in order to answer the requirement of a changing industry. These type of heat exchangers have, of course, many advantages. They are both reducing the OPEX and the CAPEX of the installations. They have a really high efficiency, and they have a small footprint. So you reduce the cost of installation, of transportation, of erection, and engineering related to the start of operation. But also, they are modular. So you have an easy maintenance that both allows you to access the heat transfer surfaces, but also has a really high corrugation. So you get high turbulence that have also a self-cleaning effect and reduces the amount of time you actually have to open and close the heat exchanger. The modularity also helps for easy capacity adjustments. So it increases the flexibility of the systems. You can put in or take away plates in case of changes in the operative conditions. We also have a product that really works well for applications in which leak resistance is crucial, and these are the semi-welded heat exchangers. Each other plate is welded with a laser here, and there is a gasket on the other side. So you can optimize, you can get all the advantages of a gasketed plate heat exchanger, but you get the extra resistance of the laser weld on the one side. This product can reach up to 63 bar in design pressure, and as all the other gasketed plate heat exchangers, up to 210 degrees Celsius. I just want to close up my session by sharing with you a really nice case story with a partner with the customer that we have a really long-lasting and nice collaboration with, that is EDF. With them, we are managing to cover the entire portfolio that we have. We start with them by identifying, exploring all possibilities. We have been very successful in technology conversion, and we have used also the semi-welded technology for the new reactors that will be built in France. during the start, we really work with them together to standardize our offering and making sure that we can help them reducing the cost and the effort, documentation reduction, and spare parts planning for the entire fleet. And but we don't forget, of course, the huge install base that we have with them, and we have a frame agreement in place for that. And we are still providing spare parts for units that are more than 60 years old. And also, we are there for the optimization part. We offer online consultancy for capacity extension, even on installations that are going beyond what was already planned as the capacity extension. With this, I will give my word to my colleague Ron, that will bring you forward for the rest of the portfolio.
Thanks, Cleo. So, now I have the chance to talk. So I had to stand there for quite some time. But now I'm having the microphone. Yes. All right. I just wanted to say something that adds to Cleo's presentation. She reminded me about 60 years of operational. So we still have spares for units that are 60 years old. Well, Alfa Laval is very stable as a company. We have been here since 1883. So that's really a long time. And we will be around for the next 100 years. So that's also a really fun or a really nice perk that you have with working with this international company. So, but nuclear reactors are changing, and so are we, because we need to adapt to new types of applications. That's why we are expanding our portfolio. So we have seen the workhorses, semi-welded and gasketed, mainly used for cooling. And we have several other products that have a wider span of range in pressures and in temperatures. So if you take, for example, the Alfa Nova, that can go up to 550 degrees. So you can reach a little bit further than with the traditional gasket heat exchangers. And that opens up for new possibilities. If the pressure goes up to 200 bar, we can make the switch to header and coil in the right top corner. And that can handle temperatures up to 975 degrees. So these are used, for instance, for molten salt systems. And if the pressure really gets high, you can also make the switch to printed circuit technology, right at the top here, 1250 bar. I'm not sure if you can reach that in an average reactor. Well, we can manage with this technology. I'll show you a few examples of what you can do. So this is a typical example of an interchanger for molten salt, and it's based on printed circuit technology. We have designed some printed circuits for a total power output of 50 megawatt thermal. So if you need more, you can design like 2 units together and put them in parallel. If it's a smaller application in a pilot plant, you can use the Alfa Nova. So you can see here, smaller type heat exchanger, but still very capable, and it still offers the efficiency that plate technology has to offer. And if you want to see the real power of plate technology, you have to take a look at the corner. This is an example of heat exchangers, plate type heat exchangers. You can see that in the right top corner, those 3 boxes. Those have the same capacity as 6 of the shell and tube type heat exchangers that are shown in the left corner. So you can see the size difference. But it's not only the size, it's also the capacity, because they have the double capacity of each shell and tube, which is huge. And this is especially important if you want to build something with a new SMR technology where you are making things smaller, because you're limited in footprint and you're limited in space. And that's where the efficiency of plate type heat exchangers comes around the corner. Now that takes us away from plate heat exchangers. So this is actually a shell and tube type heat exchanger. It's another example of an innovation that Alfa Laval has done. And this is a 4-in-1 design of a steam generator. So what you can see here is actually a complete boiler house just in one cylinder. It's actually a coil that is fueled with molten salt, so heat coming from the molten salt. And the fluid, the water comes in at the top, it's preheated, then evaporated and superheated, and then it comes out at the top. The salt can come in, and it can drain out if it's now I'm missing the words here. If it solidifies, you can reheat it with electrical heaters, and it can drain out from the bottom. So it's super safe to work with. And we have already created one and it's about to be delivered. It's a 2.5 megawatt thermal system, but we can also create one of 10 megawatts. If that's not big enough, you can again connect the technology together, make multiple installations in parallel, but sometimes that's simply not big enough again. So then we move to header and coil. And header and coil is a special type shell and tube that's especially designed for molten salt use. Molten salts are particularly difficult to handle because they can be corrosive, and if you use traditional construction methods, it could be that the tube sheet is suffering from corrosion because there is crevices inside. In header and coil, we have solved this problem by carefully rerouting the tubes into this header, and then there's no more crevices. The coil is also folded in a certain way that allows for quick expansion. So if you have a change in load or in operation, the shell of the header and coil can quickly adapt to the new load changes, and it responds very fast. Well, we can make two types. We can build a system, and we can even design a complete system where we create a complete steam generation system with a steam drum, two vertical header and coils that produce the steam, but also a preheater and a superheater, etc. And what you can see here on the schematic, this is the vertical one, and on the right side, this is actually a working system that's currently in operation. This is a horizontal one. You can see here, this is the steam generators with all the tubes coming out, going into the steam drum, and that allows for a very tiny setup. At least it's big equipment, but it doesn't take up so much space as you would normally expect. Then an example in SMR. This is a design that we did. It's actually two horizontal boilers generating steam. This is a little bit lower temperature, so we only are reaching 570 degrees, which means that we can use the standard alloys that are available, like carbon steel, stainless steel. They will still work. If you go to higher temperatures, we will simply adjust the alloy to meet the temperatures. So we can manufacture this in basically any metal. It has a total pressure of 150 bar. So that gives you a little bit of an idea of what we can do as Alfa Laval in different technologies. But basically, what we are looking for is, because Alfa Laval has a lot of technologies around, and what we are looking for is co-development, because you have the expertise on your reactor or on your technology, on your plant, on your project. We don't have that knowledge. So, but we can come together, and perhaps we can solve the heat transfer let's say, struggle that you are facing for your reactor or your project, and we can solve it because we have already thought about these things in the past. It's just that we need to know how things operate. How should we design things? What kind of fatigue can we expect? And that's where you come in, and you can help us. So if you are working with us, you get access to the R&D development of Alfa Laval, and we work on a strict confidentiality. We have state-of-the-art technology, and we can leverage that for your project. So, and that's one of the key messages. So I would like to invite you to come talk to us and explore the opportunities. So you're all invited, by the way, to visit our booth at M123. So that said, I would say for 60 years, we have kept nuclear cool, and for the next decades, we will keep it revolutionary. So it's time to go for the workshop. So take out the phones and start scanning.
Yeah. So if you start scanning the code, then I think you can switch one more. Yes. So the 4 topics that we have prepared today are first about technology conversion. So what would it take for you to adopt the plate technology as preferred solution when designing heat installations? And that would be with me. Then we have services. What challenges do you see with maintenance, and what services would you need during operation? That would be with Bertrand. And then we have regulations. What work in terms of regulations would it be needed to standardize the heat transfer equipment? That would be with Ron. And then we have the last question. How can heat exchangers contribute to modularization in nuclear and lower the investment cost? That would be with Evgeny. Yeah. So if you can choose what you would like to talk talk about, and just come to the one of us that will be discussing that area. We will be moving to the other part of the workshop room, so you can come there and talk to us. Yeah.
Yeah. So maybe to repeat.
Yes.
It's with me for regulations, Bertrand for services, Yevgeny for modularization.
And me for technology conversion.
Exactly.